In this video, I'm going to show you how to solve a simple logarithm inequality. Whenever you're solving an inequality, you're going to wind up plotting a key point on a number line and then using test values to see where the solutions are. So to find the key value that goes on the number line, you start by solving the related equation, log base 3 of x equals 2. Now to solve this equation, it's super easy. You just rewrite it in exponent form. So the base here is 3, so if I just bring that down, the x and the 2 basically switch sides, but the 2 is going to become an exponent. The x comes over here. So that tells me that x equals 9. So this is my critical value, and I'm going to take that and put it on my number line. All right, so let's say this is 9. Now for logarithms, 0 is very important, so you should always include 0 on your number line. You can't take the log of 0, that's undefined, and you can't take the log of any negative number. So if the graph ends up going to the right, then that's fine. It'll just go to the right. But if the graph ends up going to the left, you got to be careful, because this would be wrong. All right? A logarithm graph can't go to the left forever. It has to stop at 0. So if that happens, we're going to stop it at 0 with an open circle, and the answer would look like that. So let's see which case it is. Is it going to go to the left and stop, or will it go to the right? First of all, the critical value itself, where it equals 9, will either be an open circle or closed circle. Since we have the or equal to line under it, we want to include the value of 9 where it's equal to 9. So now we're just going to pick a test value either on the left side or the right side. Now I'm going to cheat and look ahead. I mean, technically you could pick any value you want. On the left side I could pick 8. On the right side I could pick 10. But whatever number I pick, I'm going to have to wind up plugging it back into this log function. So say if I picked 10, then I would have log base 3 of 10 is less than or equal to 2. I can't do this without a calculator, so at the very least, it'll be a hassle. I got to deal with the calculator. At worst, if I had a mean teacher that didn't let me use a calculator, then I'd be in trouble. But I could do this problem without a calculator if I just pick the test value wisely. So I'm asking myself, log base 3 of something. I'm going to pick a test value that I can do the log of in my head. For example, 27. It would be easy to do the log base 3 of 27. So I'm going to pick 27 for my test value. Okay, I shouldn't have put an equal sign though. I use the original symbol for the problem now. We're substituting back into the original problem. Okay, so at this test value, I want to see, is this a true statement? Is 27 a solution? To evaluate this, log base 3 of 27, I'm just asking myself, 3 to what power will be 27? What power turns 3 to a 27? That's going to be 3. 3 to the third power is 27. So on the left side, the value of that is 3. So by picking my test value carefully, it makes it super easy. So 3 is less than or equal to 2. Is that a true statement or a false statement? That is false. That's a great big no. That means 27 is not a solution. That means the solutions must go in the other direction. All right, let me stick with green. So if this side is a no, that means the other side must be a yes. The solutions must be over here. So just be careful not to just go forever. All right, we will have to stop at 0. So put an open circle there. So as far as the graph of the solution set, there you go. As far as interval notation, we're going to say from 0 to 9, parentheses, bracket. Of course, we use parentheses because 0 is not included. See the open circle? 9 bracket, 9 is included, closed circle. And that's how you solve a simple log inequality.